We're going to do a quick introduction to weighted means. We usually have to use this if we have data that is grouped. So notice here, I've got the GPA of every student, but I can't observe it. All I can observe are the average sophomore GPA, the average junior's GPA, and the average senior's GPA. So I don't want to treat this like a regular mean and simply add these GPAs up and divide by 3, because the 4.0, right, represents a way smaller number of students than the 2.0 does. Okay, so that 2.0 should be carrying more weight when we calculate the mean. So the formula we have for calculating the weighted mean, I'll kind of write it up here and then we'll go away from it for a second, is going to look something like this, where we go through. So our formula is going to be take each value for X, multiply it by its weight, which here is the number of students in each category. And this kind of makes sense if we think about what we're doing. I'll abstract from this formula for a second. That GPA of 4.0 represents 10 out of how many students, right? Well, 60 plus 30 plus 100, plus 10 is 100 students. And so that 4.0 GPA represents 10 out of 100 students. So the proportion of the class that's sophomores is 10 out of 100. So we're going to weight that GPA of 4.0 by 10 out of 100. And then so the next category is 30 out of 100. So weight that GPA of 3.0 by 30 out of 100. And then finally, the last GPA we have of 2.0 represents 60 students. So this is maybe an easier way to think about it, but this equation is really going to do the exact same thing. So notice if I follow this equation, I go through each X value. So I'll take that 4.0, multiply it by the weight. So multiply that by 10, add to that the next X value, 3.0, multiplied by its weight of 30. Add to that the next GPA, I'll leave off the 2.0 here so I don't run out of room. Multiply by its weight of 60, and then divide that by, add up all the weights, so 10 plus 30 plus 60, adding up our weight variable. Well, notice this denominator is going to end up being 100. And then because I'm dividing everything by the same value, I could pull this out. So I could do 10 over 100 times 4.0, 30 over 100 times the 3.0, and then finally 60 over 100 times the 2.0. It's just different ways of thinking about the weighted mean. First kind of introductory example of why we need it and how we can calculate it.